Hey everybody, this is Darren Eccles, and I'm about to do my science activity, Oobleck. I have here my setup, my cornstarch, which I had 1 cup of cornstarch. I had half a cup of water, which I added blue food coloring to. I have also extra water here, and if I need extra cornstarch. So the goal was to mix the mixture to the consistency of like pancake mix. All right. So as you see, it will pour like pancake mix. Okay. So the first thing when we're doing activities with our students, we want to let them know what our objective is. So the objective for this particular activity is to decide if Oobleck is a liquid or a solid. All right. But then too, we got to also remember when we're teaching science or doing science activities that we teach and incorporate science academic language. And because I will be dealing with primary grades, then I will more than likely have to simplify that language for them. So when I tell them, I won't give them the formal words like objective, but I'll also say, hey, we have to figure out if this is a liquid or if it's a solid. And then when we come to our conclusion or make our claim, then we're letting everyone know what we found, if it is or if it's not. All right, so it's just a matter of our grade levels that we're teaching and so forth. So I have my mixture here, and the first thing I'm going to do, I'm going to drop my hand into it quickly. All right, and I'm going to take it out, and then I'm going to slowly lower my hand into it. Okay, so the first time when I dipped my hand in there quickly, I was applying pressure to the mixture to increase its viscosity, which is, the viscosity is its thickness. All right. And then if I like tap on the top of the surface, it'll make it feel hard because it forces the cornstarch particles together. But then when I dipped my hand in there slowly, all right, it went in like I was sticking my fingers in water. It slid through it like water, and moving slowly in the mixture allows the cornstarch particles to move out of the way. All right. So now what I'm going to do, I'm going to hold a handful of it in the palm of my hand and see what happens. So as you see, when I hold it in the palm of my hand, it liquefies. All right. But then if I squeeze my fist with the palm, it becomes a solid, and then I can even roll it. So I'm applying pressure to it here, and I have a ball here, but as soon as I let go, I stop. It liquefies again. All right. So now I'm going to try and move my fingers. I'm going to move my fingers through the mixture slowly. Again, it allows me to move it like it's water, like I'm moving through water. And then when I try to move my fingers through it faster, the resistance is there, and I can almost, well, I can, when I pull my fingers out fast, it moves the bowl, it lifts it. But when I do it slowly and do it, I can't lift the bowl, what have you. So we can test the mixture's properties by adding more water. So if we added more water to it, then of course it becomes, and we stir it, the more water, the less the viscosity is broken up. The thickness is not as thick as it was. So it becomes watery. But if we add more cornstarch to it, then the viscosity, it increases. All right. So again, this is neither our claim or our conclusion is, our findings is this is neither a liquid or solid. It's a non-Newtonian fluid, which is it's a fluid dependent on pressure. So it's a pressure dependent substance like silly putty or quicksand, and it does not rely on Newton's theory of viscosity, which is things are constant all the time like water. So I can dip my hand in water fast and take it out slowly. It does not change liquid water. All right. But again, it's neither. It's a pressure dependent substance.